Okay, here we go, kids. 3U, chapter 3, assignment number 16. Let me read it. A 650 Newton student is rollerblading at a velocity of 7.8 meters per second west when the student trips and slides horizontally along the trail, coming to a stop in 0.95 seconds. Determine the student's average acceleration. Draw a free body diagram of the student sliding on the trail. What is the kinetic friction as the student slides? And determine the coefficient of kinetic friction between the student and the trail. So this is a beautiful question. It's a classic. Okay. Now they're trying to be tricky with you. Look what they've told you. They told you that you have a 650 Newton student. So this is a really tricky way of telling you that the magnitude of the weight or the magnitude of the force of gravity. Let me redo that. Got it all squished there. There we go. There we go, Mr. Z. That's a tricky way of telling you the weight of the student. Okay? A tricky way of saying that with the magnitude signs. Because if they were going to tell you the weight of the student, it would be a vector and it would be negative. But they didn't. So they just gave you the magnitude. But you got to remember that this is equal to, right? Look, the mass of the object times the gravitational field strength near the surface of the Earth. Okay? Magnitude. Magnitude. So everything is positive. So really what they're telling you is 650 newtons is equal to this product right here. And you always know what this is. Negative 9.8 newtons per kilogram. Oh, what happened there? There we go. You always know what G is. So really, these buggers that wrote this question, by telling you you had a 650 Newton student, they're really telling you, look, we want you to use this information to calculate the mass. They could have been nice and said, here's the mass of the student, but they weren't. They were nasty. They said, let's see if you know what this means. So have I even started answering the question yet? No. Haven't even started yet, and they gave you an extra step. Okay? So you use that to find the mass. Then we're going to draw the student. There's the student. The student trips while rollerblading and slides. Okay? So while the student is sliding, right, there's the force of gravity acting on them. There's the normal force acting on them. And since the student is moving, sliding, there's the force of kinetic friction. Now, you might be asking, well, sir, isn't there another force that's pushing them forward? No, there's not. That's it. That's why they eventually come to a stop. Those are the only forces acting on it. All right? Now, what do we know? We're going to let this direction, which I'm going to call west, it'll be positive. What do we know? We know that the student was moving at positive 7.8 meters per second, but then they slid. They slid for a time, so here's your time, delta t, of 0.95 seconds. They slid. Okay, they were moving at 7.8 meters per second positive, because I'm making west positive. Then they slid for almost the whole second, 0.95 seconds. So eventually, they came to a stop so that the final velocity was 0. Okay. So the first, and there's your free body diagram, by the way. So I gave that away for free. The first thing they want you to solve for is the student's acceleration. So we've been using this equation for a while. Can you not find acceleration if you know final velocity, initial velocity, and the time it took for that velocity to change? I think you can find acceleration. I think you know that equation. Okay. Next, what is the kinetic friction as the student slides? So as the student slides, they want you to find force of kinetic friction. Now I'm going to give you a hint on this because I'm not going to do this whole question for you. This is a complex dynamics problem involving friction. All complex dynamics problems involving friction can be solved by starting in the same way. F net equals MA. F net is the sum of all forces, which in this case I think is just kinetic friction, force of gravity, and normal force. You're going to get sick and tired of writing those two equations down. But that's how you solve all these problems. Okay? And then you're going to move forward from there, and you're going to solve for force of kinetic friction. Okay? I think I've given you enough hints for that. Okay? There you go. Bye, kids.